In this video, we want to talk about the partial fractions. What is partial fractions method? The partial fraction method is basically the opposite of common denominator. For example, suppose we want to add these two fractions to each other, 2 over x plus 1 plus 1 over x minus 2. To add two fractions, we do common denominator. The common denominator is x plus 1 times x minus 2. And in the numerator, simply we have 2 times x minus 2 plus 1 times x plus 1. If we multiply 2 in the numerator, then we have 2x minus 4. And if we multiply 1 in the bracket, then we have 1x, which is x plus 1 times 1 is 1. And in the denominator, we have x plus 1 times x minus 2. If you want, you can multiply the brackets in the denominator. And then we have x to the 2 minus 2x plus x minus 2. And if we simplify the numerator, we have in the numerator 3x, 2x plus x is 3x, minus 4 plus 1 would be minus 3. So finally, we have 3x minus 3 all over x to the 2 minus x minus 2. Now think to this problem. Suppose we are given this fraction and we want to write this complicated fraction in the form of the sum of two simpler fractions. How we can do this? This is basically the partial fraction decomposition method. So the idea of the partial fraction method is to write a complicated fraction in terms of simpler fractions. Now let us start doing this. So as an example, we work exactly on this expression, 3x minus 3 all over x to the 2 minus x minus 2. So the idea is to rewrite this in this form. But attention, now we have not this expression. So forget that. So how we can start the partial fraction method? First, you have always to factor the denominator. In the denominator here, we have a quadratic expression. To factor this quadratic expression, we put two brackets, x in each bracket, because x times x is x2, and then we look for two numbers that their product is negative 2 and their sum is negative 1. Those numbers are negative 2 and plus 1. So look at here. So far we know that by factoring the denominator, we know that the fractions that we are looking for have x minus 2 and x plus 1 in the denominator. But still we have to do some work to get to that point. And in the top, we rewrite again 3x minus 3. So the first step in the partial fraction method is to factor the denominator as much as you can. Then for each of these expressions, each of these factors in the denominator, we put separate fraction. So remember, the idea is to rewrite this fraction in terms of simpler fractions. So we know that we are looking for two fractions, that the denominator of those fractions are x minus 2 and x plus 1. But what is the numerator of these fractions? Of course, we don't know. We don't know what is numerator of these fractions. And so we put two unknowns, a and b, in the top of our fractions. Attention, if when you factor the denominator you get 3 brackets, then of course you have 3 fractions. For each of these factors you need a separate fraction, and in the top you have to put a, b, and c. We will see an example like this. So for now, let's focus on this example. We have 2 brackets, 2 factor in the bottom, in the denominator, so we have 2 fractions. But we don't know the numerator of these fractions, so we put 2 unknowns, a and b. Now our job here is to find a and b. Finding a and b is not so difficult. Attention, we want to find a and b such that the sum of these 2 fractions equals this. So this expression is equal to this expression. To find a and b, we multiply both sides of this equation, left side and the right side, by x minus 2 and x plus 1 to get rid of the denominator. This is the process of finding the unknowns. So for finding a and b, we multiply left side and the right side by x minus 2 times x plus 1. If we multiply left side by x minus 2 times x plus 1, the denominator completely cancels. So what we get in the left side? We have only 3x minus 3. Now we have to multiply the right side by x minus 2 times by x plus 1. So we multiply all of this by x minus 2 times x plus 1. When we multiply this in the first fraction, this x minus 2 from the denominator with this x minus 2 cancels, and then we have a times by x plus 1. So we have a times x plus 1. And when we multiply this in the second fraction, x plus 1 from the denominator with x plus 1 cancels, and we have b times x minus 2. These are simple algebraic operations. Now we multiply a and b in the brackets. So we have 3x minus 3 in the left side. In the right side, simply we have ax plus a plus bx minus 2b. Now, for finding a and b, attention, we want to find a and b such that this equals to this. First, we note that these two expressions involve x. So, we make a group with them. So, for finding a and b, we factor x from these two terms. So we have a plus b times x, or you can say x times bracket a plus b. But I prefer to write it as a plus b times x. So we factored x. And the other two terms, which are a and negative 2b, have no x, so they are just constant. They don't involve any variable x. So we have plus a minus 2b. Both of these two are constant. There is a reason that why I put a bracket around these two. It's not necessary, but it's better for us to understand this. Now, compare the left side with the right side. What is coefficient of x here in the left side? 3. So the coefficient of x, which is this here, should also be 3. Attention, we want the right side and the left side to be equal. If two things are equal, it means that everything in the left side and everything in the right side should be the same. So the coefficient of x in the left side with the coefficient of x in the right side should be equal. So we have this. A plus b should equal to 3. Now compare the constant in the left side and the constant in the right side. A minus 2b should equal to negative 3. The constant equals the constant, and coefficient of x equals to coefficient of x. So basically this equals this part equals to this coefficient. So a plus b equals 3 and a minus 2b equals negative 3. Now we have here a system of equations. Two equations with two unknowns. By solving this system of equation, we can find finally a and b. For finding a and b, you can use elimination method or substitution method. It's completely up to you which method to use to solve this system of equation. Here I use the elimination method. For that, I am going to write the second equation again, and I am going to multiply the first equation by 2. So I am going to multiply the left side and the right side by 2. Then I have 2a plus 2b equals 6. The reason that I am doing this is that I want to have opposite sign of b in the two equations. Now that here we have 2b, but here we have negative 2b, if we add these two equations to each other, we can find a and b. So we add left side to the left side and right side to the right side. What happens? If we add left side to the left side, 2a from the top equation with 1a from the bottom equation, in total would be 3a. 2b minus 2b would be 0, so b cancels. 6 plus negative 3 or 6 minus 3 is 3. So from here a is 1. Now that we have the value of a, we can plug in this value in one of these two equations to find b. For example, if we plug in 1 for a, the first equation above this equation, let me name this 1, then we have 1 plus b equals 3. And from here b is 3 minus 1, which is 2. Attention, for solving this system of equation, you can use the substitution method if you prefer to use that method. Let me show you how you can use this substitution method to solve this system of equation. For example, from the first equation, we have b equals 3 minus a. So we move a to the other side. Now we replace this for b in the second equation. Because we substitute b with this is the name of this method is substitution method. So then we have a minus 2 times 3 minus a equals negative. If we simplify this, we have a minus 6 plus 2a, attention, negative 2 times negative a would be positive 2a, equals negative 3. A plus 2a would be 3a. Move 6 to the other side, 6 minus 3 would be 3. And from here, finally, a is 1. Exactly same value with the other method. And now that a is 1, again, you can substitute this value for a in the first equation, like we did here, and you can get also the value of b. So it's completely up to you which method to use to solve this system of equations. Substitution method or elimination method or any other method that you want to use. Now that we have finished solving the system of equation, a is 1 and b is 2. So again, a is 1, b is 2. Let's back to here. If a is 1, attention, a is 1 and b is 2. So basically this complicated fraction can be written as 1 over x minus 2 plus 2 over x plus 1. Exactly similar to what we had here. 2 over x plus 1, 2 over x plus 1, plus 1 over x minus 2. Maybe you think by yourself, okay, the order but is changed. But the order doesn't matter. It's the sum of two fractions. Does it matter to say 5 plus 2 or 2 plus 5? Because it's sum of two fractions, the order doesn't matter. So it's not a problem. It's the same expression. So now we have learned the basics of this method. How we can decompose complicated fraction to simpler fraction. And the name of this method is partial fractions. So let me put a is 1 and b is 2. So this fraction can be written as 1 over x minus 2 plus 2 over x plus 1. And if you wonder why we need this technique, because when you try to find the integral of this expression, finding integral of this expression directly is impossible. So what we do is this. We rewrite this complicated fraction in terms of simpler fractions, and then finding integral of these simpler fractions is very easy. That's the reason we are learning the partial fraction method here. Also, the partial fraction method is useful sometimes in finding the sum of series. So basically this method is not only for finding integral of fraction functions. Also, in other parts of math, also we need this technique. In the next videos, we will learn more about partial fraction method. Never think that by just watching this video, you learn this method completely. There are other cases that we have to go over to learn this method completely. And then we use this method for finding integral of fraction functions. See you in the next videos.